outside the summation, but not outside the limit. We want it to. I'm not going to do that though. Okay? You'll see why in a second. It doesn't really serve much purpose because you're going to move a lot of stuff around in a second. So we'll have lim n goes to infinity, summation I equals 1 to n. I'm just going to subtract, get a 3, and then I'm going to apply 2 on n to each of the 3 remaining pieces, each of the 3 terms. Okay? So we'll have 3 times 2 on n, so that's 6 on n, plus 16 on n squared I, plus 8 on n cubed I squared. Everybody agree? I? I. Oh, by the same way. Where I is just an index, not the square root of -1. So that makes sense? How it work out? Seems right. Right, now we're going to keep moving. We're going to move the summation symbol through these 3 terms, and we're going to we're going to take to the outside of the summation symbol anything that is not dependent upon I. Because for the summation, only the I is changing. It's not changing for the summation. The limit has to keep all n's inside, but not the summation symbol.
Wait, where does the 6n come from?
2 on n times 3.
Oh, okay.
So anything with the I attached to it, we can't take it out of the brackets. We can take n out of the brackets, but we can't take it out of the sigma sign, but we can take a whole number, a real number out of the sigma sign completely, or a constant.
You can take any numerical constant outside both of these symbols.
So we can take 6 out and leave 1 in n, if you wanted to.
You gotta take 6 from everything.
Oh, you're not going to break them up?
I'm going to break it up.
Yeah,
so at that stage was broken up?
Yeah,
you take 6
yeah, you take 6 out and leave 1
That's right.
in.
Anything that has an I is going nowhere. Anything that has an N can move outside of this, but not outside of that. It'll be more straightforward. Just watch. It's no big deal. So 6 on n, sum I equals 1 to n, and what's sitting there? An invisible 1, plus 16 on n squared. Probably get an idea of where this is heading. I equals 1 to n. I'm trying to get those little formulas that we discussed at the very beginning, right? I'm trying to apply the sigma symbol so it looks like the original formulas of the constant of the I and I squared.
I thought n couldn't go out of the sigma symbol.
No, n can. I cannot. It is not changing for the sigma. Only I changes. I goes 1, I changes to 2, I changes to 3.
I thought n changed because you're changing, like delta x is changing as n is changing. Do you see what I mean? Because you're taking.
Right, but I have not applied the limit yet. It's on the outside of the whole thing. It's not doing anything yet. So it's not changing as regards to the sigma. So it can come at the outside of the sigma, but it cannot be moved outside the limit because it is changing as regards to limit. You are going to apply the sigma before you apply the limit. So 8 on n cubed, sigma I squared, I equals 1 to n. That's all still inside the limit. Okay. Now we know, yeah, Baker?
You can still use the sum rule even if it's inside a limit.
Use the sigma symbol?
Like use the sum rule for sigma, like add all the
Distribute the sigma inside?
Yeah.
You're saying, your question, is that legitimate inside a limit?
Yes.
The answer is yes, because of order operations. We're doing that first, and we're running a limit last. So as long as this n is finite, and it is at this stage, right? So whatever, let's say for this one, or this one's easier. So the sum of 1 as I goes 1 to n, where n is finite, is just the number n, just n. I'm adding up 1 n times. So since I'm doing this first, I'm just replacing this complicated algebraic expression with a more simplified algebraic expression. That's all I'm doing. And I'm running the limit secondarily. So I can do things inside the limit. The limit has not, we're not even approaching infinity yet. We're just rearranging the way this expression looks. Then we'll take the limit. There might be a little question.